Hello and welcome to this tutorial series video on the Dornier DO 31. So what are we going to be looking at today? Well, we're going to take a look at the aircraft and why it's just a fascinating aircraft, and the history and how to fly the DO 31. So first of all, let's look at the history. First flew on the 10th of February 1967, but this wasn't a vertical takeoff flight. That happened in December of the same year. 3 of them were made, E1, E2 and E3, with the E1 prototype preserved here at the Dornier Museum in Friedrichshafen. E2 was actually lost. Nobody knows what happened to the E2 prototype, and E3 is stored in an aviation museum near Munich. And the model that you see in Sim is based after the E3 prototype. So your first question might be, why does this aircraft exist? And that's a very good question. Well, at this time, the Western German government was worried about a first strike from the Soviet Union that would take out a lot of the fixed concrete and tarmac based airfields. So having an air force that was able to operate without runways was seen as a massive tactical advantage. But other countries around the world were also coming to this same conclusion, with Britain working on the Harrier, the Americans also working on other VTOL aircraft along with other parts of the world. So this seemed like the next generation of military technology coming together. Now the West German government had a comprehensive plan for their air force, with the DO-31 being a part of that. They wanted a vertical takeoff and landing supersonic fighter jet, a ground attack aircraft, and a transport aircraft, which is where we come in today. So how did they achieve this, frankly, unbelievable aircraft in the time? Well, they used a collaboration with Rolls-Royce engines. As I mentioned before, Rolls-Royce thought the future of military technology was vertical takeoff, as they had built the world's first vertical takeoff practical fighter, the Kestrel, becoming the Harrier, which is in service for many decades. And the DO-31 uses 2 of those Pegasus engines, along with 8 Rolls-Royce lift engines called RB162s. Now these were engines specifically designed for vertical takeoff and landing, which is kind of fascinating that they put all that money into an engine for just this specific purpose. But they really did see this as a major market that was emerging. Now why is making a VTOL aircraft difficult? Why don't we see them flying around all over the skies today if I've just said there's so many advantages to them? Well, there's a few drawbacks. One of them being the amount of thrust you need in the aircraft is off the scale. So you're looking at this aircraft now, it's, reasonable size, but it has 66,000 pounds of thrust, and it only weighs a maximum of around 45,000 pounds when it's in hover mode. So it's got way more power than it even has weight. So it has a thrust to weight ratio around 1.1, 1.2, something like that. Now, the A310, which is an incredibly overpowered airliner, at its maximum weight has a thrust to weight ratio of 0.26. So massively less, right? So you need to carry all of this weight and all of these engines with you all the time, just so you can be able to take off vertically and land vertically. The second biggest challenge is controlling the aircraft, because when you're hovering, you're not flying. I mean, you are flying in the air, but the wings are doing nothing. They're just dead weight. So you need to be able to control the aircraft without using the ailerons or using the rudder, and this all needs to be designed, and this is where Dornier did an unbelievable job on this aircraft. Due to the complexities of this, they actually invented a hybrid digital and analog supercomputer called the DO-960. Now this was actually used after the end of this program in various applications around the world because it was so good, but it needed to be built to be able to process all of the different inputs in real time of pitch, thrust, weight, all this sort of things like that to be able to try and control the aircraft. When in the hover mode, the controls that the pilots input actually change what they're doing to the aircraft because it's now not using the ailerons and rudders as we said, so how is it doing it? Well, in pitch, there's a split nozzle at the rear which pitches up and down to control the pitch of the aircraft. And for roll, left and right, the lift engines on the end of the wing are throttled up or down. And for yaw, they're actually twisted back and forth so they can tilt 15 degrees to yaw the aircraft. And this is all mixed together via that Dornier supercomputer to give a stable hover output, which is crazy in the 60s. So as you can tell, Dornier solved that controllability problem, but they were never able to solve that weight and fuel problem, because that's just a physical limitation, but no one else was able to solve that as well. Pretty much all of those vertical takeoff aircraft I talked about were cancelled or never got into really serious production, with only the exception being the Harrier really. It's about the only aircraft from this generation that was really quite successful. Everything else kind of just went by the wayside because of the issues mentioned here. Ultimately, this led to the West German government cancelling the program in April 1970. Still an amazing achievement to be able to build an aircraft of this type, regardless if it went into series production. We're going to go into the simulator now and do a walk around of the aircraft to take a look at some of these features and the visual model in Microsoft Flight Simulator. Okay, where do we even start on the exterior? There's so much really cool stuff to look at. So let's start at the nose. So as you can see, there's a large probe that comes out the front of the aircraft. Now, what was this used for? Now, this was actually a pitot tube, as you can see right on the end here, to be able to gather air that was not disturbed by the airframe. Now, you can actually remove this in the EFB and fly around with or without it, as it did fly with either, but we've given you that option. Moving a little bit closer, we have this fantastic looking canopy. Now, I really think this is such a unique looking canopy, but it was there for a few practical reasons. Now, when you're doing, landings, hover takeoffs, you need as much visibility as possible, with as much references around you as possible. So that's why the canopy was given as much, basically, glass as possible. And also underneath the aircraft, which you can just about see from here, was a very small little window which can be seen up from the flight deck to allow more precise landings when you're in the hover. Coming up very close to the aircraft, you can see there's a lot of really good attention to detail throughout the airframe, all using decals and the modern methodology, so you can actually read this up close as well, along with the tyres. Once we move a little bit further back, we're going to see the Rolls-Royce Pegasus engines, as we talked about. Now, these Pegasus engines are extremely unique, with the black nozzles in the center here rotating throughout 90 degrees to be able to direct that thrust either fully backwards for forwards flight or fully down for the hover. And you can actually see here, it's a really cool little view, you can kind of see inside the engine, see that? And you can just see the front disc on the housing, and I don't know, I just love being able to see inside these engines. Down here as well, we have fully retractable landing gear, along with the connection up to the wing on the wing spar. Moving towards the end of the wing, this is where the lift engines are stored. Now, these are those 4 engines. As you can see, we've got 4 little plates here, and the doors do open and close at the bottom and the rear to give airflow in and out, and they'll close up again to reduce drag to allow quick forward flight, basically. Moving towards the rear, we have this split nozzle. Now, you can see it says danger, keep away. Now, this is because this nozzle will be firing some extremely high pressure air when it was in hover mode, giving that pitch control as we talked about earlier. This is the rear cargo door. Now, the rear cargo door can be opened via the EFB, and this is where they were able to load in a 3-ton truck or 36 troops. So that was the lift capability of the aircraft. Moving up, we've got rather a large fin, which it didn't really do much in the hover. It's all there for static weight, but I imagine that this is quite far out of the airflow here to stop being interfered with the nozzles in forward flight. Mirrored on the other side, you can see the other lift pod, but also it gives you a good view of the wing here. It's a rather small wing. The wing is pretty small for the aircraft size. That is again to keep the weight down, and also the fact that it's only used for forward landings, and VTOL can be done as well. If we come to the rear of this Pegasus engine, you'll see that there's sort of a metallic plate here that's got a little bit of wear and heat wear on it. Now, this was actually a heat shield, because you needed to keep this heat blast that was coming out of the back of the Pegasus engine fully away from the engine housing here. Moving towards the front of the aircraft, this was one of the entrance doors and allowed crews to enter and exit the aircraft, so you call this sort of the standard pilot entry door. Okay, so you join us on the runway now, ready to go. Now you can get into this state by simply loading on the runway in the sim, or using the in-sim checklist system, which is found at the top here. These are fully integrated and will work with the autocomplete function as well. So what we're going to do is a conventional takeoff. So if we look down at the pedestal, we can see we have quite a few thrust levers, and we also have a flap. So the flap is set to 15 degrees for the takeoff. Now if I move my thrust lever up and down, you can see it's just moving those central two thrust levers. Now those are those Rolls-Royce Pegasus engines, and the nozzles, if we move into the nozzle control section here, are set to 0. So basically they're pointing all the way back, and we can go across here. These are the lift engines. You can see that they're turned off, and they're also at 0 because we're just going to be doing a normal conventional takeoff. So it's as simple as this: looking down, releasing the parking brake, and then increasing the thrust up, and go full power, and we can see RPM here, so N1 as sorts, and then the temperatures here as well. And we just keep ourselves centered. As you can see, pretty fast, because it needs all this excess thrust for VTOL operations. So when, you know, flying conventionally, pretty straight, pretty fast, pretty straightforward, and also quite sporty. So if I now rotate off, there we go, positive climb, gear can come up. It's definitely no slouch when it's in the air. So see, we're climbing still 160, 170 knots. Now, famously, one of these Dorniers at an air show actually did a barrel roll. It's not certified for negative G operations, but let's give that a go now. So if I just push the nose down, there we go, gaining a bit more speed, pitch the nose up and roll. It's more of an aileron roll than a barrel roll, but still, you can see it's absolutely not a problem at all for this aircraft. It's really quite maneuverable, left and right, and quite a pleasure to fly in conventional modes. Okay, let's talk about how we're going to have the controls set up for this vertical takeoff that we're about to do. So first of all, let's set on the control options, and we're going to be showing you how to do it today with an Xbox controller, a normal flight stick, and also if you have a few more peripherals plugged in. Let's first start with my joystick, which is a Logitech Extreme 3D. And the things that have changed are under power management and throttle. So as you can see, I'm moving this axis now. What I've done is assigned throttle axis 1 and throttle axis 2 to my main throttle. So I only have one, remember, so I've assigned it to that. If you have one throttle axis and two throttle axis, perfect, assign them to that. Now we have throttle 3 increase and throttle 3 decrease. Now this is slightly different. Now this is controlling the thrust from those lift engines and the nozzle direction. Now if you have a third throttle axis, you can assign this to throttle 3 axis. And that's actually the most realistic way to do it, but of course most people don't have 2 or 3 independent throttle axes. But if you do, do it that way. If you don't, do what I've done here, where I've assigned these to 2 buttons, so 9 and 10, so here and here. That's personal preference. Whatever you work best for you, you set it wherever you want. Okay, going across to the controller, we'll see the differences as well under power management. Now, as you can see, similar to the Logitech, we have throttle 1 increase, throttle 2 increase, both set to A, throttle 2 decrease, throttle 1 decrease, both set to B. So those Pegasus engines, that forward thrust is controlled by A and B. Now for the lift engines, rather than have it on button 8 and 9 like I had on the joysticks, we've got it set to right bumper and up on the D-pad, right bumper and down on the D-pad. So that will increase those lift engines along with moving the nozzles. Now to actually fly in the hover, I personally find the easiest way to do it is to have your left hand on the joystick, your right hand on the bumper, and then your thumb over on the increase decrease. So the reason for that is you're then not transitioning between constantly taking your hand off, putting your hand on, taking your hand off, putting your hand on. That isn't going to really work. So you kind of want to have it permanently covering the controls so you're ready to make these fine adjustments. that is how we're going to set it up. And now what we're going to do is go ahead and do a VTOL takeoff and talk a little bit more about the technique. All right, let's try a vertical takeoff. So what do we need to do? First of all, we need to tell the aircraft, hey, I'm going to be taking off VTOL. So we press this button up here called Co-Pilot Vertical Engine Control. Now in the real aircraft, this was a 2 test pilot aircraft, so everyone was extremely busy, and the co-pilot was taking control of the nozzles and the thrust, and as the pilot you were just flying. So what we need to do is make sure that we get the lift engines started up. Now we do this by, remember, pressing the buttons on the joystick or either the up or down command on the Xbox controller. So obviously I'm going to move it up, and you can see that this switch automatically just went to start, and this is in the start position. So now the lift engines are starting up, so we need to wait for them to start up so they actually have a realistic start time. And why you might add why they're not running all the time. These things burn an enormous amount of fuel. When I mean enormous, I mean if you sit here for, I don't know, 15 or 20 minutes, you're going to run out of fuel. Literally from full tanks to that's it, end of story. Which was obviously part of the problem of the aircraft. So now, when I move my throttle axis, so remember this one here, it doesn't do anything because it's controlling the forward-backward thrust. So we're not going to be touching that at all, right, for this vertical takeoff aspect. We're just going to be using the up and down command on the Xbox controller or the buttons that we've assigned on our joystick. So I'm going to leave the parking brake on just to prove it's a vertical takeoff. I'm then going to get in the air, and then what I'm going to do is I'm going to increase my thrust axis. Okay, so in this case it would be the same one we used for takeoff, and that's going to move the nozzles forward, and we're going to transition into forward flight. So here we go. This is always, I find this just fascinating that we can actually do this. So thrust coming up, see the nozzle here, nozzle degrees is moving, so when I do this it moves up, when I do this it moves down, and you can see it also moves the nozzle degrees for the lift engines. So I'm going to go all the way to full, which is 90 degrees, and then we should take off. There we go, full power, and we're in the air. So now we are actually flying, and you can see I have pitch control, I have roll control, I have yaw control, all coming from the engines being throttled up and down. We're actually are doing that in the sim. So now I'm going to push the nose forward, put the gear up, and now what I'm going to do is press A on the Xbox controller, and you can see it starts with this. Now we need to power back the actual lift engine slightly to see to 60. So just hold it here about this pitch, something like this. A little bit less, and now we can turn them off. So we select it to 0, and bingo, look, we're in forward flight. Now I'm not touching the controls, and there we go. We are actually in forward flight. And it's, I don't know, I just find it absolutely fascinating that that it works, and it really does work, you know. And it's not easy, I might add. Okay, this is not the easiest aircraft to fly. We've tried to simulate some of that challenge because none of this flight model is being overridden. This is actually all engines being throttled up and down to control your pitch and yaw and roll. So it's working realistically like the real one, and that means there are some challenges when you transition from lift to the wing basically stalling, and then you can actually get into the hover. Alright, so we're downwind now to try and come back for a hover landing. Now, let's talk a little bit about these gauges here. I didn't want to overwhelm you when we're on the ground. Now, this is pitch, of course, so pitch up, pitch down, and angle of attack. Now, these are very important gauges. So, if you see, if I increase my angle of attack up, that's getting dangerously close to the stall. Now, what we have to try and do when we're in a vertical takeoff and landing aircraft is slow down while also increasing the thrust to the lift engine. So what I'm going to do now is I'm going to start the lift engines back up. So remember, we have first of all have to put it into the hover mode, and then I have to increase this power up here. So now those lift engines are starting up, and the lift engines, there they are, they're online now. So what I'm going to do is start to slow down, but also at the same time increase that nozzle degree. See? So I'm increasing it up, increasing it a bit more, Speed is coming below 100 knots, so this is where we'd normally be completely stalled, yeah? So I'm going to put the gear down, holding that 7 or 8 degrees angle of attack. A little bit more. 60, 70, 40 knots, and now I'm going to go full up with the nozzles. And there we go. We're basically in the hover now. Now you see the angle of attack increasing massively? Bingo, because the wing is now stalled. The wing's not doing anything, right? But look, we're in the hover. See? So I'm actually hovering. You can actually look at that. Look and see our shadow down there. And I can yaw to the left, yaw to the right, and you can fly around like this. So we're in the hover. Okay, so we're downwind again. So let's go through what we're going to start again. So put this in to the start mode. We are going to increase the throttles up to put to the start position. Look back forward again. Speed is decreasing now. As you can see, look, between 5, 7, something 10 degrees angle of attack. So 5 and 6. I'm coming to idle on the Pegasus engines. There we go. And I'm going to turn to the left now. Start to keep about 150. You don't really want to go below 150 without the lift engines on. And I'm going to put the gear down, just to try and help with the drag. Now, we can use the flaps as well. So let's start to take the flaps out. These just help us slow us down, because of course, when we're landing, we're not using the wings. So let's have a look. Airport's off to our left. Yes. Okay, so what I'm going to do now is, you see the nozzles, the engine's already on. So I'm now going to start to increase the thrust on the nozzles. So we're looking here. So speed is coming down. I'm keeping a constant sort of angle of attack and a little bit lower pitch. There we go. Let's put a bit more flap in. I'm going to go all the way now. There we go. Speed's coming back. Everything's nice and gradual, right? This isn't the sort of thing that you're going to throw into a field and just vertically land it, because we're kind of trying to make this realistic, this process of slowing down. We can trim back a little bit. Trim back a little bit more. Angle of attack, you see, is around 9, 10. It's quite high. There's the airfield off to our left. Going to increase a little bit now to about 60 degrees on the nozzle. And there's the runway ahead of us. I know this seems rather slow and sort of slowing down on final approach, but the reason for this is you want to be able to do this in the first sort of approaches to land, because if you try and do it all in one go, it's going to go wrong. I'll be honest with you. This takes quite a bit of practice even to get it to this point here. So I'm just going to slowly keep coming down here around 60 knots, 60, 70 knots, until we're over the runway, and then we're going to put it into the full hover and come to the land. So now you can see we're coming over the threshold, slowly reducing the speed back, slowly but surely below 40 knots now. And now we're slowly, very shortly going to be entering the hover again. So now I'm still increasing the nozzles up. They're at about 88, 89 degrees. I'm looking at the left side of the window. And full back on the nozzles. And see, there we go. Now we're in the hover. So now we're in the hover again. So now I can reduce the thrust back a little bit. Now this can kind of be a little bit tricky because it requires nearly all of the thrust of the aircraft to try and maintain this. Full power now. There we go, down on the brakes. Oof. Not the smoothest of landings, but I'll take it, right? It is not an easy aircraft to fly, as you can see. It takes technique and it takes time, but that is part of the... I really enjoy it personally, you know, the challenge of that. Now, let's get a little bit more ambitious. Right? So we're going to take off. We're going to try and hover around the airfield and try and sort of come back and probably land on the runway in the other direction. Just to show you that once you get the technique down, you can comfortably-ish fly the aircraft around. So here we go. So I'm going to increase the power up on the lift engines, brakes to come off, and we're in the hover. So now I'm going to start to come over to the left here, And you can see, look at the nozzle direction. I'm going to slightly reduce it like to about 88, something like that. That gives a nice little bit of forward thrust as well. So we can kind of hover around at around 20, 30 knots. Here we go. This is the apron where we started earlier. And we get a good view of the museum. Over there we can see the E1 prototype just off to our left. So we can go and say hello to that one. And there you go. You can see it off the left, parked there outside the museum. Now we're getting a little high, right? So what we want to do is reduce the nozzle back down again. So, I don't know, 70. But pitch the nose up. There we go. See, the angle of attack is increasing, so we're losing our speed back again. And this is a great way to start to get custom with the aircraft. So I'm comfortable with my altitude, but I want to... Well, I'm actually pretty comfortable with the speed. This looks pretty good now. I'm pretty happy with this. So you can see you can get pretty ambitious. And now what we're going to do is do a 180 and land back on the runway. Now how are we going to do this? Of course, roll isn't really our friend here. So we're going to use yaw. Now remember, this is thrusting up and down some of those engines on the exterior. And of course, yawing it round now like this. That's about as quick as it can yaw, which is, to be honest, fair enough. And there is the runway. And now what I'm going to do is bring the nozzles back a little bit. Bring this forward. Pitch the nose up to try and lose that speed. So we've got the nozzles a little bit, 40 knots is a bit too fast. So you see the nozzles are about 70 with the nose up. So now the speed is decreasing again. So now we need to bring the nozzles back up again. This is very hard to commentate and do all at the same time, I might add. So excuse me if I go into my concentration mode. Now I can see we're descending. It's looking good. A little bit more. See, I almost lost it off the hover there. That was a good demonstration of when you almost lose the control. So now I'm going to bring the power back because we're in the hover. There we go. Full power. A little bit less. A little bit less. Oh, she's looking nice. There we go, down. And cut the lift engines. Now that was a workout. I didn't commentate that as much as I thought I was going to. But we just took off, hovered around and came back. Now, what is there else to say about the Dornier DO31? But it is a fantastic piece of fun. I really haven't had as much fun as this flying an aircraft in the sim as before. Because it's a challenge. And when you get it down like I had there, it puts a big smile on your face. You can go from helipads into cities, from other things to this. It's got a 900-mile range. It'll go 300 knots, roughly. What more do you want in an aircraft? I think it's just an absolute massive piece of fun. And I really, really hope you've enjoyed. Follow me along today, going through the history of the aircraft, how to fly it. And we really hope you can see it and enjoy it in sim together as well. Thank you very much.